Alright, in this algebra video, we're going to take a look at the difference between a direct variation function and an inverse variation function. We'll take a look at what's similar and what's different. A direct variation equation has variables that vary in the same way. Either both the variables x and y are increasing together, or both are decreasing together. The equation is in the form y equals kx. Y equals kx. K is just another way to say slope. So if you have a y equals a slope times x, that's a direct variation. The graph is a line that always passes through the origin. Your constant of variation is called k, which is just another representation of slope. There is no y-intercept in the formula of this equation because the y-intercept is at 0. An inverse variation equation is a little bit different. This is where variables vary in the opposite way. When one variable increases, the other decreases. The graph of this is not a straight line. It's a hyperbola. It kind of looks like a boomerang in my opinion. They never cross the x or the y-axis. The x and the y-axis are actually called asymptotes of the hyperbola. If you have a graph on your screen, you can notice that your hyperbola is in quadrant 1 and quadrant 3. You also might see one where it's in quadrant 2 and quadrant 4. But notice how it never goes through the origin. It never touches the x or the y-axis. It gets close to them, but never quite touches it. The graph of the hyperbola is in the equation y equals k over x. Notice that in both direct and inverse variation equations, you have a k, you have a y, and you have an x. They're just in different places in the equation. If k is a negative, the inverse variation branches are in opposite quadrants. K is also called the constant of variation. It's that value of k. It's really the slope in your direct variation equation. Take a look at some graphs, and we're going to identify which one shows a direct variation, inverse variation, or neither. So here we have our first graph. It is definitely a line, and it does not go through the origin. Is that a direct variation, inverse variation, or neither? This one is neither neither. Can't be an inverse variation, because that's where I have that boomerang type picture. And it's almost a direct variation, but a direct variation goes through the origin. This one does not. So this one's neither direct nor inverse. Our next graph is a line. It does go through the origin. Is that direct variation, inverse variation, or neither? This one is direct. All right, what do we think about that next one? It's kind of like, horseshoes that are side by side there. And this one is also a neither-neither type of graph. Our last one, it looks like we have that hyperbola. It's not touching the origin, doesn't touch the x or y axis. This one is an inverse variation. We'll be able to take a look at a table of values and figure out if it is a direct variation or an inverse variation. In order to do that, we just want to go ahead and solve either the direct variation for k or the inverse variation for k. In a direct variation, this equation here, you would end up dividing both sides by x to see what the constant is. So if you look at your table of values and you divide y by x, and it's the same number for all of your table of values, then you have a constant value for k, and your equation is direct. If that doesn't work, then you go ahead and solve this equation for k. You end up multiplying your x and y values. You would repeat that process for every element in your table, multiply x and y, and see if you have that constant k value. If you do, then your equation is an inverse equation. Well, let's take a look. Given the table at the right, does it describe a direct or an inverse variation? So in this table, I either have a direct variation, y equals k times x, or I have an inverse one, y equals k over x. This one's direct, this one's for inverse. So I'm going to go ahead and use my calculator and test some things out. So I've got 2.4. If I divide that by negative 3, if I divide that by negative 5, I get negative 0.48. I'm going to try the next one. I take my y value and divide it by my x value. This one I got negative 0.133 repeated. Well, it doesn't look like I have the same k here. I got two different values. Time to try inverse. So inverse says I multiply my x and y together. So I'm going to do 2.4 times negative 5. I get 12. When I do negative 3 times 4, I get negative 12. When I do 4 times negative 3, I get negative 12. And so on and so forth. So this is an inverse variation. What is my k? It's right here. It's negative 12. So what is the equation? Well, my equation is always in the form y equals, so I have to write y equals what my k is. My k was negative 12, and we leave x to be x. We're just replacing the k when we figure out if our table is direct or inverse to write our equation. All right, go ahead, you try it. You've got direct, inverse, or neither. If direct or inverse, what are the equations? Go ahead and pause your video and decide by multiplying your x and y together, if it's an inverse variation, or dividing y by x to see which you have. Go ahead and pause your video. Taking a look at our first table, I started by saying, okay, maybe it's a direct equation, so that means I would take y and divide it by x. 15 divided by 3 is 5, 25 divided by 25 divided by 5 is 5, and 17.5 divided by 3.5 is 5. So I lucked out on my first try picking if it was direct or inverse. So my y is equal to 5x. I just replaced this k with that constant of variation that I found. For my next table, I started out the same way. I said, okay, my y divided by x. 1.4 divided by negative 10 gave me negative 0.14. But negative 7 divided by 2 gave me negative 3.5. So I knew, okay, it's not direct. Maybe it's an inverse. So I took negative 10 and multiplied it by 1.4. Negative 7 and multiplied it by 2. Negative 1 and multiplied it by 14. And I found negative 14 to be my constant. So this means it's an inverse variation. My equation is y equals negative 14 over x. My last table, I tried dividing, I tried multiplying, and I was getting different values for k. So this one is a neither-neither situation. It's neither direct nor inverse. We can identify and write direct and inverse variation equations. All we have to do is convert equation to a function form, meaning solve for y, and put it in slope-intercept form. If my b is 0, then we have a direct variation equation. So let's take a look at A. A already is in the form y equals mx plus b. If that b is 0, it's a direct variation equation. Is this one direct? No, because I have a b and it was 2 instead of 0. My next one, I'm just not sure. I've got to solve for y. So I'm going to subtract 2x on both sides. I'll get negative 3y equals negative 2x and divide by negative 3. I get y equals 2/3 x. Is that a direct variation? It is. My k is 2/3 in that case. My next one, I'm going to solve for y, and I end up with y equals x.
Would Medina please report to the front?
This one is not a direct variation because I have a b. Going ahead to solve my last one, I've got negative 5y equals negative 4x. Divide by negative 5 on both sides, and I'll get y equals 4/5 x. This one is a direct variation equation. You have some more practice problems, E, F, and G, so go ahead and take a moment to pause the video and try those. For E, when we solve for y, we get an inverse equation. For F, when we solve for y, we get direct. And for G, when we solve for y, it already was, we get neither neither. Our next example says the variables x and y vary inversely, and y is 6 and x is negative 3. Write an inverse variation equation. I start with the form y equals inverse k over x. I know my y is 6 and my x is negative 3. So I'm going to go ahead and solve for k because I need to know that constant of variation. In this case, it's negative 8. I haven't written my equation yet. I go back to the form y equals, and I only replace the k in my equation. Part B says find the value of y when x is 4. Okay, well I just go ahead and plug in with my new equation that I found, my x value of 4. And this one I'm going to simplify. That's negative 9/2. Number 2 says the graph of a direct variation passes through the point 4, 6. Write the direct variation equation. Well, I know it's going to be in the form y equals kx. I know the y, and I know the x. I'm going to solve for my k. In this case, my k is going to be 3/2. So my direct variation equation is y equals 3/2 x. Part B says find the value of y when x is 24. Well, okay, I'm just going to go ahead and plug in 24. And we should get a value of 36. My y is equal to 36 for that one.